Good afternoon, everybody, or I guess it could be morning or evening or the middle of the night where you are watching from. I am GI Director Brad Keeler. We are very happy to have everybody with us today for the first national live streamed Cross USA lecture of 2021. If you don't know much about the Geo-Institute, it is time that you did. We are a technical society housed within the American Society of Civil Engineers. We have about 12,000 members, primarily geotechnical engineers and geologists who study and work on a wide variety of different things. You can check out geo-institute.org for a lot more information about that. Now, the Cross USA lecture. Geo-Institute started the Cross USA lecture in 2010. It was primarily a way to get world-class speakers out to our chapters, professional and student chapters that maybe were in more remote areas, different parts of the country that didn't typically have these types of people coming to them. Over the years, it's been a great success. We've had people like Jean-Louis Briod, Bob Holtz, George Fills, Bob Bacchus, and this year, of course, Liz Smith as our lecturers. The deal is they go to at least 5 of these sites that bid to have them lecture every year. Somewhere along the line, someone, I think it might have been Jean-Louis, decided he would put everything to the test, and he did something like 22 lectures during his year. And since then, the pattern has been more and more Cross USA lectures, which is fantastic. We're able to deliver this content to more and more of our members and more people in the geotechnical and civil community. Who chooses the Cross USA lecture? It is a joint deal between the GI Board of Governors, the Local Involvement Committee, and the Graduate Student Leadership Council. So they put their heads together every year, come up with a list of candidates, select one, and the rest is history. That person then travels the country, or in the case of the last year and a half, does some travel and a lot of talking via Zoom and Teams and GoToMeeting and all kinds of other web apps that allow them to reach out to the people. So thanks again for being here today. Again, our topic is geotechnical engineering for design build projects, and Liz Smith is our lecturer. Liz is a senior principal and national transportation program manager at Terracon Consultants. She has over 35 years of experience. I want to point out that if you read Liz's bio, it looks like someone cut and pasted 3 or 4 people's different career achievements in there, because there is literally so much to it. Her expertise has been all over geotechnical engineering, but specifically in design, build transportation projects, slope and retaining wall failure evaluations, remediation. She's been involved in several other areas of transportation engineering over the years, include design build teams to resolve geotechnical problems on complex projects, owner oversight, and evaluation and repair of foundation, slope, and retaining wall failures. Liz has over the years been very active in GI and the Deep Foundations Institute and many other organizations that are too numerous to mention. They're all up on the Eventbrite page. I would urge you to take a look at her bio. She's incredibly accomplished. We are thrilled to have her here today. If you have any questions for Liz during her lecture, be sure to put them in the box to the right of the video, the chat box. We will try to address all of the questions after Liz's lecture is finished. So without any further hesitation, I bring you Liz Smith.
Wow, I hope I can live up to the hype. All right, well, I'm going to give you a little presentation about geotech engineering and design build projects. It's kind of a simple overview with some tips that I've learned through the years. I've written several papers about this topic, and if you're interested, we can probably put a link to the titles and stuff if anybody's interested afterward. I actually go back and read some of those papers and go, oh, I forgot about doing that. I forgot about doing that. It's like, oh, I have really great advice. It's like, how did I think of that before? Anyway, so let's get started. I'm going to go through our little outline here. I'm going to talk about what is design build, the procurement process for design build, at different aspects of the design build team, the way the project is formulated, how we can manage risk, and then some lessons learned. So, of course, the first thing is defining design build. So I'm going to have little pictures on throughout the presentation of different projects I've worked on. And this is one of them that you can see in this screen. So design build is a procurement method, and it's selected by the owner. And I'm going to talk solely about transportation design build because that's what I know. I haven't ever done a building design build. So the owner, which is going to be typically the DOT or a local agency, will identify a project which has to be included as part of the State Transportation Improvement Plan, which is called the STIP. It's mandated that the major MPOs, the Metropolitan Planning Organization, any city with more than 50,000 people has to have an MPO. And so you have, in Austin, we have what's called CAMPO, Capital Area MPO. We also have toll authorities. So in Texas, we have different ways of putting out projects. Most states, it's done by the state. In California, I think they also have some counties that will do projects like this. So the procurement method is basically design build. And what it does is it allows the project to be delivered faster and with cost savings. It's advantageous to the owner because they have a single responsibility. They have one contract, and that is with the design build contractor. And they push the risk of that project onto the design builder, so that you end up with reduced risk to the owner and reduced litigation claims, most typically. So throughout this presentation, I'm going to put little slides up of some of the design build project I've worked on. And this is the very first one. This was the Eastern Transportation Corridor, and it went from Interstate 5 in 2 different locations up through the canyons up to State Route 91. And this was an interesting project. I was working for the lead design firm at the time, and we had all these bridges that had to be built through the canyon in order to actually access the canyon to build the rest of the road. And there was a big bottleneck with getting some reports approved through Caltrans. And so the design build team brought me in to be a liaison between Caltrans and Silverado constructors. And it was pretty successful. We got 55 bridge reports approved in 4 months, I think, which was huge. It was able to get the contractor continuing to move forward. And ultimately, they ended up finishing the project early, and they got a big bonus because they finished the job early. And that there was incentive for them to finish early, but I like to think that I helped. All right, so let's talk about the procurement process. So I'm going to say the state, the DOT, whatever entity it is, issues a request for qualifications. And then teams start forming as they learn about, oh, this project might be coming out in the next year, next 2 years. And so they start forming teams, and it's just really who you know in the industry and, who have you worked for before and who's comfortable with whom, that type of thing. So the teams form, and then you have a qualifications submittal, which is pretty small typically, and the design builder puts that together. They submit it to the state. The state goes through those documents that they get, and then they shortlist the most qualified firms. Typically, it's going to be 3. I've seen it up to 5. We don't really like it when there are 5 different people competing because there's a lot of effort that goes into this process. And when you have, only a 20% chance of winning, it's just not as palatable to do that much work when you only have a smaller percentage of winning. So once the short list is completed, they issue a request for proposals. And this is going to be, the RFP has all of the basic contract terms that are going to be in the design build agreement, as well as technical specifications and all the things that you need to look at in terms of what they're going to expect when you do this project. So during the procurement, when the RFP is issued, we basically have schematic plans of the road. And so we have to take that 10% schematic and come up with a preliminary design, which is more like a 30% design. And we develop this design in conjunction with all the different disciplines, the contractor and everything. And they use that preliminary design to come up with the quantities so that they can do the cost estimate. Of course, the engineers all have to put in their pricing for the technical and price proposal. So typically you're going to submit a technical proposal and a price proposal. They usually don't go together. If they want to do a best value, the technical proposal is separate from the price proposal. And then they rank the technical proposals, and then they have a weighted value on the price proposal based on whoever's lowest in the price proposal has 100%, and then it takes away as you get more expensive. And then ultimately the project is awarded to one of the teams, and then you go into final design and construction. So this is the basic process that you go through on any design build procurement. This is the Otay River Bridge. I worked on this when I was in San Diego. In fact, it's one of the reasons I moved to San Diego. The lead designer wanted us to do the designs for the major bridges on that project, and they insisted that I had to be the project manager. I had to live in San Diego. So we moved to San Diego, and I did the preliminary design for this project, and then everything got hung up in environmental, and I just didn't stick around. I moved to Texas, and I finished 2 more jobs before this job was finished, but that's part of design build. Things change all the time. So by the time the RFQ, the request for qualifications, is issued, a lot of work has already been completed by the state. All the environmental studies, the documents, the record of decision is either approved or it's pending. They have prepared this 10% design schematic. The public knows about the project. They've probably had public meetings. Funding is identified. And then all the existing information that goes along with that project, the owner's probably done some surveys, they've done some geotechnical borings, and all of that information gets put together in what we call a RIDS document, which is the reference information documents. Excuse me. And these are all part of the contract, the reference information documents. This is US 70 in Hondo, New Mexico. It goes from Ruidoso Downs to Riverside, and this was a very windy mountain road. You can see there's a mountain on one side, and there's a water body that runs along the toe of this entire alignment. This road curved back and forth, and there were tremendous accidents along this corridor. And I was on a team where we won this project, and it was a pretty good job. It was fun because we had rock cuts, and we had fill slopes, and we had bridges, and we had retaining walls. The lead designer chose to do all the vertical retaining walls, those designs, and we did pretty much everything else on that project. So the design build team includes the design builder, which can be a joint venture of more than one firm. One of my recent projects was Interstate 35E up in Dallas. It was a 30-mile long highway. And on that project, we had 3 contractors as a joint venture: Archer Western, Granite Construction, and Lane. And so it was AGL Constructors. A lot of times they come up with names for the joint venture. In New Mexico, it was Hondo Valley Constructors. I can't remember. It's been too many years. Anyway, they come with names typically for their design build team. They hold the prime agreement with the owner, and then they have a lead designer or two. It can be one large civil firm, can be a joint venture of one or two more firms. And they're contracted directly to the design builder because the design builder holds the prime agreement. And then you have, of course, your geotechnical engineer, near and dear to my heart. And we are typically an independent geotechnical firm. We're subcontracted to the lead designer. So you have these tiers of engineering firms that work under that main agreement. And then there are all these other disciplines, and we use a lot of acronyms. So there's drainage. MOT is maintenance of traffic. SU is subsurface utility engineering. ITS is intelligent transportation systems, right-of-way, public involvement, and quality assurance and quality control. So there are a lot of people on these teams. This was the first project that I did in Texas, 183A up in Cedar Park, and it was the first toll road by a local agency, which is the Central Texas Regional Mobility Authority. So this was their first project, and it had a lot of interesting challenges, but in my opinion, it came out good because we were able to save a lot of money on some of the designs we did. This project had karst features, expansive soils, bedrock, creeks, you name it. It was fun. So teaming on a project like this is super important. And having the correct experience is the key to a successful project. So when you're talking about teaming with other firms, you need to look at, well, have they done design build before? Because if they haven't, there may be inefficiencies in the ways that they do things. That goes the same for the contractor. If you've done design build before, it's a lot easier for them to understand the things that go into a design build project. You also, when I work on a project, even if it's out of state, I have to be up to speed and work with my local counterparts to understand the local standards and the local practices, because there are things that happen in every different area with different types of soils that if you don't understand them, you could make some big mistakes. You can say, well, I thought this was just this. It's like, yeah, but we know that material in this location does these things. It also helps if you know the agency or their rep, because a lot of times you'll have the owner and then you'll have what they call the general engineering consultant, the GEC, works for the owner because the DOT doesn't have enough people typically to manage the entire project by themselves. And so they bring on experts from other areas to help them with the report reviews and design reviews. And they obviously know the local soil issues. Sometimes, there's some complicated or unique design elements that have to happen on a project. And you have to have people who know how to do that because the pace is very fast and you can't get up to speed and just figure it out while you're doing the design. So sometimes you have to commit specialized people to your team, but you also have to commit specific people like your project manager or your technical lead or the drainage lead. Whatever firm it is, you may have to, and typically you do, have to commit specific people, and you say that you will commit those people. This is the Christopher Bond Bridge in Kansas City, Missouri. This was the center of a project I worked on. We did all the foundation engineering explorations and lab testing for this. Another firm actually did the foundation design. We did the oversight. And then there was 15 more miles of project, and we were responsible for the entire rest of the project, and they peer reviewed our work. So it was a nice teaming arrangement. So, I mentioned, the teaming, and even if you're like on a dream team or something, you still have to go through this go, no go process to identify, is this the right team and is this the right project for us? You don't just say, sure, I'll be on your team, and then, disaster could happen. So if you need to look at who's the owner's rep, and what is their experience previously? How have they dealt with other design build projects? Were they super difficult? Were they pretty straightforward and pragmatic? There are a lot of different things can really cost you a lot more money if the owner is difficult. You may have to resubmit and resubmit and resubmit these reports or calculations, and oh, well, we found this error, you need to resubmit. It's like, it takes a lot of time to resubmit. And so if they haven't done design build before, you can look at what their reputation is on traditional projects, design bid build, and how easy or difficult are they to work with on those types of projects. Because if you go from that type of project to a design build project, everything's going to be amplified in terms of reviews. You're going to have so many reviews of all the work that you do, and different owners have different, very specific things that they want to see in the projects. So that's one of those flags that you have to look for. Same thing with our teaming partners. Have we worked with the lead designer or the design builder before? Do we know the project manager for that's proposed for that team? Do they have a reputation for being litigious or slow paying or not paying? Those are red flags. And if they do that on a design bid build, they're going to do it on a design build. And then finally, the project manager's experience is really a very important element. And that is the project manager for both the contractor and the lead designer. If they don't manage their team well, things can go in all sorts of directions because the pace is so fast. This is the 281 Loop 1604 project in San Antonio, Texas. We did big flyovers at the 281 1604 interchange, and this is a photo of when it was under construction. This was an interesting project. We had shallow rock, but we also had karst features. So we drilled a boring at every single one of these foundations because we were concerned about the karst features. That was interesting. It was a fun project. So when you agree to be on a team, typically you'll get a teaming agreement. And if you don't get a teaming agreement, then you're not really on the team, because this is a contractual document that commits that you to that team and that team to you. It says we're going to use you for this effort for this project. And usually when you're on a team for something, that whole team goes to the next phase if they win the job. And so you want to make sure that your teaming agreement isn't just for what we call the tender phase, the proposal phase. You want to be committed to carry on and do the full design, because during the tender phase, there's usually some sweat equity you have to put in. We typically will get paid for the proposal effort by the contractor, and that's part of the stipend that the different contractors, the losing contractors, will get a stipend from the state, and then they use that money to pay the team members. But you come up with a budget for doing the proposal, whatever your sweat equity is. If we do field work, that's usually paid directly. If the contractor wants us to get extra borings or geophysical tests or something, they pay for that at our cost. And if they win the job, usually we get made whole We have a reduced multiplier for the proposal phase, and then we go back up to a normal multiplier during the for final design, and they match that full multiplier for the work we did during the proposal phase. So it's like a success fee. The teaming agreement also identifies your roles and responsibilities, the key personnel, again, that you're committing to this project, and you have to commit to confidentiality, because a lot of times the brainstorming sessions during these teaming meetings, during the tender phase, you're throwing out alternate technical concepts. You're trying to come up with a better mousetrap. Well, you can't share that with other people. So I've seen a lot of people say, well, why can't we be on more than one team? Well, because we're helping them come up with an innovative solution. And if you're on more than one team, there's no way that they can be confident that you're not sharing information, because you have a relationship with the other people on the other team. So typically it's compartmentalized. You pick a team, and that's the one you stick with the whole time. This is a State Route 121, Chisholm Trail in Johnson County, Texas. This is what's called a Super 2. It's a toll road. It's only 2 lanes with a barrier, and it's super because in some areas they move everything over and they have a passing lane. But the fun thing about this project is this was a complete greenfield project. There was nothing out here but cow pasture, horse pastures, stuff like that. And so we were able to do our field work without any issues, during the day. And as the geotech engineer of record, I made the contractor, whenever we put in fills at a bridge abutment, I made them monitor the settlement, and they weren't allowed to place the pavement until I told them they could. This is the smoothest pavement in Texas, I'm telling you. I had my husband drive down this road one time for me, and I was in the passenger seat, and every time we went over a bridge, I was like, no bump, no bump. It was so exciting. There were no bumps at the end of the bridges. So monitoring is an awesome thing if you can talk your contractor into doing it. Okay, so let's talk about the proposal. The proposal is a major project effort. Depending on who you're working for and the level of effort, the size of the project, I've had proposals that have values of, on a normal size project, $200 million, $300 million project, our fee can be $100,000 for the proposal phase, just because there's so much work involved in developing these 30% plans. We have to come up with foundation recommendations for all the foundations, for all the walls, any other things that are going to come up on the project, embankments and slopes and pavement, all these kind of things we have to work on during this procurement phase. We also help the contractors come up with ATCs, which is an alternate technical concept that may not match with what is in the design specs, but it's another way that we propose. You come up with an ATC, you propose it to the DOT, and then they either accept it or reject it. But it can be used as a way to either speed up construction, reduce cost, make things more efficient. There are whole different ways that ATCs can work, but you can't do them unless you submit them during the procurement phase. So during this, we prepare a written technical proposal that outlines how the contractor is going to do the job. Typically, as geotechs, we work on just a couple of sections defining the geotechnical investigation and testing, things like that. We don't get into a lot of the other design things that are involved in the project. That's the lead designer or the other specialty designers who do those who do those tasks. So once we come up with the design, we have to prepare the design schedule. Well, the contractor prepares a design schedule and the construction quantities. And then the designers all have to prepare an estimate to complete the job once they win. And the contractor develops their construction cost estimate, and they marry that all together, and then they determine, okay, how much wiggle room do we have? How hungry are we? What do they actually submit? We're never privy to that, to what the bid is until after the bid opening. But during this phase, when you have to put together your own, the geotech schedule and the geotech level of effort, you have to understand that these projects are not like a conventional project. The people who are going to work on the project are going to be full-time, and they're going to be interacting with the designers and the contractor. And if you normally say, well, we can do a design for a bridge for this many hours, well, that's on a normal bid build job, because you don't have somebody coming back and saying, why did you pick those? We want to change the foundation types. Okay, so then you have to redesign everything. And so there's a lot of redesign and reevaluation and resubmittal of documents that goes on in design build that you have to plan for. And if you plan for this to be a normal project, you're not going to make any money, and you're probably going to lose money, and nobody's going to be happy. So the considerations that I want to talk about in our proposals the considerations are, we have to write up our detailed design scope. We have to tell them this is what we're going to do. And we have to identify and talk about these risk items that include quantities. So if you make recommendations for bridge foundations, for example, and then during final design, we have to make the shafts 10% longer, they're going to say, well, why didn't you tell us, why did you give us this number when all of them are longer now? And they're going to want to come back to somebody because now their foundations are longer. You don't want to be too conservative, but you don't want to be too aggressive. And so a lot of times what we have to do is explain to the contractor, okay, so here are the options we have, and help them work through what those risks are and make sure that they're aware of these things, and then have it documented, because they can tend to come back to the designers and say, well, it was your mistake that caused us to overrun, and so you owe us this much money. And it happens a lot, and it's not pleasant. So that goes back to choosing your teammates and so forth. But understand the quantity risk, and it's a very real risk. There's also schedule risk, because if we do a lot of field investigation and by the time we get our reports done, they want to be finished and we're still doing lab work, that's a big risk. We have to crank up the volume here. There are risks on any site. You could have karst features, you could have hazardous materials, things like that. And then the final risk, I call it the people risk. And I'm going to talk about this a lot more in a later slide, but you have to have the right people on the project, and you have to be able to have them. You actually have to identify who they are and then get them to come work on the project. So that's a big risk. And the design costs, as I said earlier, are not the same as it would be for a conventional project. So if you normally say, and I'm just throwing this out there, we can do a 2-span bridge for 100 labor hours. Okay, that's great, but you may not be able to do this 2-span bridge for that same number of hours because of the coordination and collaboration and the review cycles with the designer. You have a review cycle with the owner, and then they come back with comments, and then it's a do loop almost. So the costs are not the same. So let's talk about these team members and what makes a good team member. And I've seen all kinds, but a good team member respects others. They're a good communicator, they're professional under pressure, they enjoy the teamwork and the collaboration. If you don't thrive on teamwork and collaboration and working with others really close to come up with solutions, you're not a good candidate for design build, because there's meeting after meeting where we're talking about, okay, how do you want to build this? We can do this or this. And, it's not just a one and done. It's, you talk to the contractor and say, well, we could do this or this. Which is your preference? How do you want to build this? And then they tell you how they want to build it. And so then you design it according to how they're going to build it or stage it and things like that. I think it's fun. But you also have to have a good sense of urgency. You have to be decisive, but not hasty. You have to be able to think outside the box, ask a lot of questions, be open-minded to what other people have to say, and then you have to compromise a lot. Not necessarily on things you really think you should compromise on. And when that happens, you have to document why you compromised. This is a project, speaking of team members, this is a project I worked on, the State Route 520, which is the east side approaches to, it was the approaches to the floating bridge. And this is in Bellevue. And when I was working on Chisholm Trail, the one that I said had the best pavement, the contractor pulled me aside and said, we need you to go to Seattle. I was like, but this is going so well. And they said, yeah, that's why you need to go to Seattle. And so I ended up flying to Seattle in the middle of Chisholm Trail because they had a landslide in this area right here. You can see there's a home right there, and the freeway is right down here. And they were very concerned about the wall designs in this particular unit. And essentially, I did the back analysis of this slide and ended up having to redesign all of the walls in this geologic unit because the communication had completely broken down between the design builder's geotech engineer and the state's geotech engineer. And it was not pleasant in those rooms. I mean, and it happens, right? It happens. So we ended up redesigning these walls, and the project looks great now, but it wasn't fun. So when you choose your staff for the project, some people just don't fit. And this is really a crucial, really critical concept, that if you have somebody who's a bully, or it's my way or the highway, well, they don't belong in a design build team. You can't bully someone into designing something the way you want it. That's just not workable. There are other people who can be indecisive. They work at a really slow pace. They have sloppy work product, inattention to detail. This is one of my pet peeves. We have a full quality control, quality assurance process we have to follow in all of our work. So if you're going to do a set of calculations to determine the foundation recommendations, you have to prepare a calculation package that someone else can follow with the step-by-step procedures, and then it has to be checked. And if there are changes, it has to be corrected and then verified that it was corrected. There's a big quality process that goes for any submittal, and includes calculations, drawings, reports, you name it. It has to go through this process. And if you work slowly or if you're sloppy, you're going to get a lot of comments. And that you just don't have time for that. I've had other people who've had mediocre performance, or they want to argue with you about stuff. Asking questions is fantastic. I love people who ask questions, but don't argue with me when I'm telling you this is the answer and you don't want to do it. That's not going to work. That will get you sent home. And this is something else that I've learned, that the leadership, whether it's your company or within the project, the leadership has to react quickly to team members who don't fit. And I'm sure all of you have been in a situation where you have a group of people and everybody gets along great. And then there's one guy or gal who throws the whole dynamic of the entire group off. And then one day, you know, maybe they're not there and everybody's like, wow, it's so pleasant today. Yeah, that person's a problem. And if you let it go on during your design process, because the design process can be a year or 2 years, you can't let that, it's going to fester and people are going to get very frustrated. And so you have to be decisive as a leader to say, this person's got to go. You're not working out. Sorry, see ya. And yes, I have done that. And it's crucial. You have to make those decisions when you see that this is not going to work out, whether it's a safety issue or just a personality issue, whatever it is. If there's one person who doesn't fit, they're not going to be successful, they're not going to be happy, and the rest of the team isn't going to be happy. So that's something that as project managers, we have to recognize. And on here, I say bad fits can occur on any side of the project. I know of one it was a huge design build project, and the relationships were so bad from everywhere that the state basically said, okay, the team, the leaders of the oversight, the GEC oversight, the state and the contractor and the lead designer they fired everybody and made all of those groups bring in new leadership because they were having so much infighting and the project was going nowhere. And ultimately the goal is to deliver a project to your client. And if you're fighting amongst yourselves or with each other, you know, your side, my side versus state versus design builder, it's just not going to be productive. And it really harms the morale on the project performance. So when you see something that just isn't going to work, you have to react. And this is one of the hardest things. I think I've probably terminated at least one person on every job. Just for whatever reason, but you have to be prepared to do that. This is the 35E project in Dallas, and I was observing a drilled shaft construction, and normally I didn't go out in the field, but on this day, the person who was supposed to be in the field had a doctor appointment or something and couldn't make it. And so I went out there, and of course it was dark when I showed up. And I turned around and I looked around and I said, look how clean this site is. Look at all the safety practices that are going on. This is a drilling bucket right here. And then we have all these columns that are being formed, and, you know, they have a safety walkway around this one. There are barrels around. There was actually, you can't see it in this picture, but there was tape in the swing radius of this excavator. And it was just a really cool picture with the sun coming up. That was an interesting project. It was a lot of fun, a 30-mile highway widening. I think the construction fee was $1.2 billion. And we did all of the geotech on it, and we did a good job. We were able to innovate on it and come up with some new methods that weren't normally accepted in Texas. So I consider that a very successful project. The only problem is, we finished that job we started in 2013. So I think we finished it in 2015. And the contractor stopped paying the designers because they said there were errors it was a quantity thing between the proposal phase and the design phase. And, you know, we didn't get sued. I was deposed and had to go to court and testify, but we still are owed $1 million on that job. So many years later, and it's still in court, but those kind of things can take forever. And if you don't have the ability to forego payments of $1 million, you know, it can be a real hurting thing for your, especially smaller companies. All right, let's talk about the project. So the project is very fast paced, and you have overlapping designs at the same time. Everything happens, the whole thing is evolving. So you have roadway, designing the roadway and looking at, okay, and then drainage is looking at the drainage, and wall people are trying to look at walls and bridges. And then the roadway people go, well, we can't make this work. So now we have to shift this over, and then it moves your wall, it moves your bridges, and things just, it's constant. It's just constant movement and concurrent decisions and things. And so that's why I made this like a loop. You do design, you coordinate, you adjust the design, you review. And if it comes out okay, great. But typically then you have to go back to the top and do the design and coordinate and adjust and review again. So when you prepare your proposals for something like this, you have to say in your proposal, look, I'll do this X number of times, but after that, if it's because of owner preference or contractor preference, we have to get paid for the extra effort because we came up with a feasible design and now you've changed your mind, or the state has changed their mind, or whatever it can be. You can't continuously do this for every single design element and think that you're going to make money. And I've had to remind contractors sometimes that, look, I'm not going to be in business if we don't make money. That's part of what we have to do, just like you. We have to be able to make money. And, you know, we're not here as a pro bono free service out of the niceness out of our hearts. And then sometimes these problems occur because the scope requirements are flawed. And this is one of the reasons you want to try and identify those during the proposal phase in the RFP to say, are you sure you want to do this? Because they may have mistakenly put something in the scope or left something in the scope. And I mentioned the reviews. So when you're doing design, you have a design review. You have an independent design review, interdisciplinary, design review. So the design review is your people, right? You have a wall report you're going to prepare, and then you have a senior reviewer who goes through our stuff, and then you submit that, and then it goes through a review by all the lead designers as well as the contractor, and then you address those comments and you revise it, and then you submit it, and then the owner reviews and comments, and then you go over the comments. You have to meet and either agree or disagree or come up with a solution on areas of disagreement so that you can revise your design and then resubmit it. And then you go back into this loop again. And eventually you will get popped out when they finally agree to everything and your documents are released for construction. But this right here can become a do loop as well. So, oh, and you have to document everything. So you have to use the quality process checklists and things like that to demonstrate that, okay, yes, this was checked, and you have to have the check print stamp, and there are all these processes you have to follow. So if you don't pay good attention to detail, you're going to have problems with your calcs, but you're also going to have lots of problems as you go through this design review and submittal process. This is the border highway in El Paso, Texas. This was a design build project that TxDOT, the El Paso district of TxDOT, put out. And this was a really interesting job. We had very large diameter shafts. These are trains back here behind this. We had the road and we had train tracks right next to it. And then we had this giant structure because the river was on the other side. The Rio Grande was on the other side, and we had the border. I think this is the border wall right here. So it was very interesting of a project. We were brought in late to the game and ended up fixing some of the designs because there were some problems. And I can't comment on what they were, but this is one of my female engineers, and she was pregnant at the time, and I had her stand up here next to this giant auger. It's like, oh my goodness. Yeah, these were, I think, 10-foot shafts. So what are the lessons learned here? As I mentioned, you have to have a clearly defined list of things in your proposal and your cost estimate showing how many bridges there are, how many walls, and any other features that are in the scope. Because scope creep can happen really fast, and it can just blow up on you if you don't have that documented. Look, we said we would work on 82 bridges and 115 walls, and now you guys have redesigned this and we have 150 walls and more bridges or whatever it is. You have to be compensated for that. So that's one of your ways you can say, well, we planned X number of borings for X number of linear feet of drilling, and I've had a contractor, the designer, come back to me and say, well, you didn't drill all the borings you said you would. And I said, oh, yes, we did. They were adding another bridge for a flyover for some reason. And I had to go back and show them, look, these are the quantities we proposed. This is what we've done. And if you need us to do that bridge, it's extra. I was like, oh, yeah, okay, I guess you're right. Like, yeah, I know how many borings we drill. So you have to put that in your proposal. We end up in the proposal phase submitting memos on design recommendations and things like that. But you have to submit an actual proposal, a written proposal that documents all this information that's going to be part of your scope. Because if you don't, they're going to say, well, you said you would do whatever it took. And it's like, yeah, no, that's not how this works. If you can, identify the plan foundation system early in the process. Some areas are driven piles are great. Other areas, you got to go with the drill shaft. And some places you have to have casing or other things that try to identify those things really early on, because the bridge engineers need to know it. The contractor needs to be able to buy into what it is that you're proposing, so that you don't end up having them say, well, I want you to look at 6 different diameter shafts, and I also want you to consider driven piles. And well, what about auger cast piles? Or we don't want to hear what about. We want to identify what that is and move forward, and not run around with our heads cut off trying to look at every different permutation of a foundation type. And like I said, you want to include what's in your scope, but you also have to say what you're not doing. And one of the biggest things that I always say we're not doing is traffic control and surveying, because we're not surveyors. The lead designer or the contractor typically does the surveying. Traffic control can be provided by the contractor. A lot of times they like to do it because it's cheaper. They have their own people available, they do the traffic control, and then we don't have to sub it out. But traffic control is a very pricey line item, as well as survey. So make sure you say, we're not doing this, this, and this. We're not doing our shop drawing review and borrow pit evaluations are not part of our scope. And so then when they want you to go do that, you say, hey, that's great. I'm happy to do that. Here's our change order for us to go get that information for you. And they don't, it's very clear. Nobody can fight with you because you've already said that I'm not doing that. That's not part of my scope. I didn't price that. Again, identify what would trigger a change order. And we have in some of our recent projects, it's like, once we submit our final report, if you make changes that require us to rewrite the entire report, that's a change order. I also put in certain durations. Anything, if we agree to be on site for 18 months, beyond that, you have to pay us more. It's pretty straightforward. And usually nobody has heartburn about that, because it makes it easier on both sides. They know what your requirements are and what you said I'm not going to do. And so they won't argue with you later on. This is Interstate 66 in Virginia. This was another project that we were working on, and our team was not doing very well. And so I got pulled into that project and ended up taking over the designs with a very demanding client, very demanding owner. And this is an interchange at, I believe, 495 and I-66 in Fairfax. I don't have a lot of construction photographs. I had to steal them off the web because I was there for 2 years, and then I said, I'm done. And I came home because I commuted to Virginia from Texas for 2 years. So lessons learned. This is going to be kind of repetitive, I think, but explain the limitations of the field program. And I had a contractor say this to me once. What do you mean you didn't know there were soft soils there? I said, there were no borings. When we proposed this, we didn't know that there were borings that were completed in that area. And I said, look, this is why we do a field program, to identify these things before construction. But we didn't put it there. And, we need to do a drilling plan to identify what is there. And it was kind of like, they thought we just drilled borings to confirm. It's like, oh, no, we do them so that we can design for whatever's there, and we can't see everything. Identify the timing of deliverables and constraints. Now, different owners have different requirements. If you have to submit your bridge plans with a bridge foundation report at the same time, that's great, but we have to have the information that's on the bridge plans in advance to do our design. If they have to match, it depends on the owner. What level of information is needed at different stages of design. Sometimes they want everything, but they don't. It's like, you're not even going to use this data right now. You need to get written authorization before proceeding with any work. On some projects, we've been asked, can you start early? It's like, sure we can, but we need a contract for that early work. And, you don't ever agree to do any work without something in writing. It can be an email. You're authorized to do da-da-da-da-da-da under our tender phase agreement, and here's the amount of money that we will pay you for that. But you have to have it in writing. Your field work is going to take typically a lot longer if you're doing a transportation project, because you have work hours like from 9 to 4 when you can get in the freeway. So you have a small window of opportunity. Well, that includes setting up your traffic control. So you have this window of opportunity. You have to set up traffic control, do your borings, and then tear down in time for them to take everything back up. Or you have to do things at night. So you have to plan for those types of things. It's going to take longer to do your field program than it would if it was a greenfield site. One of the things that I insist that my field folks do is take a picture before and after drilling. And I don't mean I don't want a picture of the stake. I want a picture of the drill rig in the location prior to drilling, showing that here are the utility markings. Here's where the boring is staked. We're getting ready to drill. This is what it looks like before we start. And then when you finish drilling and cleaned everything up, backfilled the hole, pulled the augers out, whatever, and you're getting ready to leave the site, take another picture that shows how you cleaned up the site. Because I just got a letter from a property owner in Virginia 3 years later saying, well, you did this work on my property. I was like, what are you talking about? We left the property in pristine conditions. He's mad because they were going to buy part of this property, and then they got rid of the pond that was going to go there. So he's like, I need to be compensated. You did some borings there. It's like, yeah, we had right of way. Anyway, you have to document that before and after drilling. Always follow dig safe or dig test or whatever it's called, and make sure there's some utilities that are not going to be on the utility maps. High mass lighting conduit, for example. Found that out the hard way. We drilled right through this copper wire. I was like, huh, what is this? Well, it was a high mass light that was had a sensor on it, so it only turned on at night. Well, we drilled right through the power to it, but it was off because it was daytime. You know, that cost us, I think, $17,000 to fix one little copper wire. And then my last thing is never build a wall with a toe slope. I know that they say you can do it, but of all the wall failures I've seen, a lot of them have a slope at the toe, and you know, I've just seen that they're not terribly stable. Okay, so this is my second to last slide. This is Oak Hill Parkway. This is a project in Austin that we're working on right now. This shows a multi-level interchange of 290 and 71. It's kind of a controversial project because there are these heritage oak trees out there, and the contractor had notice to proceed, and they just did the groundbreaking, and now they're stuck in court because the community doesn't want them cutting down any trees. And they have some trees that are, you know, listed for preservation, but not all of them. And so we have to wait till September 4th to see what's going to happen with that. But we're proceeding with our designs because our field work is finished. But, you know, it's always something. And okay, second slide. Here's what I think are keys to a successful project. Co-located teams perform best. And the reason I say that is if you have the designer and the contractor and then the specialty designers like Geotech in the same building, you can go, oh, what does this mean? And you can go over to the structural engineer and go, explain this to me. I don't get it. Or talk to the contractor and say, how do you want to really build this? Is it better to do this size of shaft and make it this long, or that size and make it this long? And, you know, you can have impromptu meetings, and it's just so much more effective. It's been really, really difficult to do that Oak Hill Parkway project I just showed you. It's really difficult to do in COVID time. I think I need to wrap up. So quality management, communication, active engagement between the different participants, treat each other with respect, and be flexible because change is going to happen. And then this is the rendering of the current project I'm working on now. It's the I-35 Northeast expansion, the NEX project in San Antonio. This is a $1.5 billion project. And we're going to be doing all the major flyover interchanges and as well as some of the roadway widenings. And that oh wait, there's one more. I thought that was done. Here's something else. Sorry. Always deliver bad news right away. My team found this out one day. We had a bridge that was supposed to go in and had big retaining walls. And when we drilled it, we found out it was just, it had been dredge mined and it was slop. And there's no way we could have put a retaining wall there. But my team didn't want to break it to me. So I just happened to find out and I went, oh my gosh. And I ran down the hall and left everybody standing there and they went, where'd she go? Well, I went down to the project manager's office to tell him. I just found out that because you're not going to get beat up if you tell them. But if you don't tell them, it won't go away. You don't have to know everything. And don't guess, just get help. Call somebody who's an expert. You have to keep organized. You have to keep your lists and your schedules and, I mean, spreadsheets everywhere. As a project manager, you have to delegate as much as possible. But recognize that anybody can be replaced. Anybody at any time. And the project will continue even if you take a vacation. So take your vacation because you're going to need it. that concludes my presentation.
That was really good. Thank you, Liz. I think couple of things I'll say before we get into the questions. One, that I-66 project you had up there is about 1.5 miles from where I am sitting right now. It's very near and dear to my heart. I think things are better after that than they were before. And it probably some days took you less time to commute to Virginia from Texas than it does for some people from Maryland to get to Virginia.
Yes, I have no doubt about that.
So we have a few questions from the audience. I'm going to ask one from me first, and I have a ton, but we might not get to all of these. One of the reasons that we choose specific people for the Cross USA lecture is the wealth of experience that you've accumulated over the years. What aspect of the design build process do you feel like has changed the most during your career?
Okay, so the contractors have gotten much more litigious with their designers. And I'm not sure why. But, you know, it used to be we worked together and we were a team and we came up with solutions. And I've just seen that attitude change. And maybe it's just certain contractors. I'm not sure. But I've never before had somebody withhold payment to the team for so many years. And we weren't even listed as part of the problem. Drainage is usually a huge problem. And, you know, it's just that quantity risk. So, yeah.
How do you guys manage that on the fly then? Because you had a slide in there about, it was on the staffing. No, it was actually on the go, no go one. There was a bullet on reputation, and that's great if you know that stuff in advance. But I'm guessing a lot of times you don't know in advance and you find out halfway through. What do you do?
I don't think that's really true. I mean, somebody has worked with this agency or this contractor before. And nowadays, contractors aren't just teaming with firms. You have to go and interview to be on their team. And they'll interview several different design firms and they'll interview different geotech firms. And, you know, who are you going to commit to the project? And, you know, they want to know all these things up front. We don't get to interview them, unfortunately. We have to just talk to our colleagues through the Geo-Institute, DFI. You know, you have to network and say, have you ever worked with these guys? It's like, oh yeah, but don't ever work with so-and-so. You know, that's part of your homework that you have to do.
Okay, great. Let's get to a couple from the audience today. The first one, what are your feelings on exclusivity as a subcontractor?
You have to do it. Because if you're doing the geotech design and you come up with some innovative way to do the foundations or something, you have to be exclusive because normally you would give the same thing to everybody. Well, if that's a winner for you and you want your team to win, you know, they want you exclusive. And I've never seen it where they've not accepted, where they've demanded otherwise. Now, the only time I've seen that before is in the construction testing area. It's like, well, you know, it's just unit prices. So it's not like they're sharing in the concepts and how can we build a better mousetrap. So I believe in exclusivity.
Now we're going to hop to something completely different. Do you have any general thoughts on design build in the water sector? And the example that our questioner gave, I actually gave two, the Lake Travis intake project in Austin or the Houston flood tunnels that are upcoming.
Yeah, we're teamed for that, the Houston project. But it's just been sitting out there for 2 years waiting. These are water projects, but it's another long linear kind of job. I don't know about the intake at Lake Travis. I don't know anything about that. I try not to get into water, but because the water project in Houston is a big linear project, and we have a group down there that's going to be chasing it. And I've been working with them and our contractors.
So then we have a comment that I'd like to get your comments on. And it is nice to know that almost everyone involved in these design build projects have experienced the same issues with scope creep, risk management, dealing with bids based on 60% design. And while I would imagine that on some level that is reassuring for people, it's also sad on some level that these issues are so widespread, and wanted to get some of your thoughts on that.
The scope creep and things?
Yeah.
Well, again, the contractor is going to try and get away with everything they can, right? I told them, I'm sorry, but we are a for-profit company, and we won't be in business if we just do things for free. And that's what I explained to them. We have to make money too. And if we didn't screw this up, or, just because you want this a certain way doesn't mean that that I have to eat it. Just not how it works. But the thing is, the way I typically propose a job, a big design build job, is I look at the project in a couple different ways. I look at it as if okay, how many hours per bridge, how many hours per wall? And then I say, well, what is the design duration? And how many people do I think I need? And if I put them in full time for that duration, that's another way to estimate how many people I'm going to need. Because typically, your folks on your design build project can't do anything else. They have to be assigned to that project, and that's it. Because the pace and the scope and things are moving so fast, and you can't just bring somebody else in to replace them and get them up to speed, because there's just so much that happens all the time. You have to just make sure you point all those things out and document. It's a big effort as a project manager. And I have a paper that I wrote. It was in GSP 137. This was the Geo Frontiers that was in Austin, Texas, many years ago. And it's called Managing Risk and Design Build, Lessons for Geotech Professionals. And that's the one I have to always read before I do a new project, and I hand it out to my staff because it talks about the teaming and the change order aspects and things like that.
And for everybody watching, we can put a link to that in the comments so you can go check it out. Well, we'll get to two really quickly here, I think, before we have to wrap up. One from me is on that staffing slide. You spent a lot of time talking about the right fit, and of course, that's super important. How do you deal with it when someone in your sphere of influence other than you comes back with but they can do the engineering thing? What's your rebuttal to that?
There's a lot more to it than the engineering thing. I'll give you an example. I had a young engineer working on a project, and he came from somewhere in the north where it wasn't as hot as it is in Texas. And he didn't understand. We were talking about heat stress and drinking enough water. And, it's a safety issue, right? And he continued to drink monster drinks out in the field. And then one day he came back in the office, and I asked him, how have you been? How are you feeling? He looked pale and clammy and like heat stress, and he said, I'm just fine. And I said, well, have you had to go to the bathroom today? And he looked at me like I was crazy. I said, if you haven't, you're dehydrated. You're not drinking enough water. You're not drinking enough fluids, and you can get heat stroke. And it's a safety issue. This isn't a game. And he wanted to argue with me, and I just looked at my assistant and said, get him a plane ticket home. He's done. He was there for 2 weeks. See ya. And his boss called me and said, but I thought you were going to train them. And I said, if you got to be potty trained to play in my kindergarten, because I don't tolerate anything that's going to be unsafe. And I also don't tolerate disrespectful.
That's a great one-liner. I love that. So we'll wrap up with this. Oh, actually, we got another one from the audience, so we'll go. Well, we know they're all coming in. As a consultant, what's your view on companies that were more traditionally geotechnical contractors gaining more in-house design capabilities, and how does that impact the market and the profession?
Contractors, geotech contractors? Is that the question?
Yeah.
I don't know the answer to that because I don't exactly understand the question.
Joe, if you're still out there, if you want to clarify a little bit, we'll be here for another minute. We had one more from the audience. How do you when your team members are working on a design build project, how do you make it clear that's the only project they can work on?
That's hard. You just have to tell them, and then you have to tell their boss, because that's really the challenge. Oh, but I just need you to do the. It's like they don't have time. They're too busy. You can't do it. I had a guy who tried to manage a department, and he thought he could manage the department and be the project manager. And I said, no, it's not going to work. And sure enough, within a month after we started, my client, the designer, the lead designer, fired him. Get this guy out of here and never bring him back. I was like, great. So, and you have to identify that. I had another guy who was just a terrible fit, and they had hired him for this project, but he had been a sole proprietor for so long that he wanted to do everything his way, and he was basically relogging all the borings in the office. I was like, you don't have time for that. And he knew it wasn't working out, and I knew it wasn't working out, but I was new to the company. And so I got my boss involved and I explained what happened. We had some meetings, and because I didn't want him to think I was being hasty. Mm-hmm. And so he ended up leaving the project, and nobody knew where he was. He didn't tell anybody. So they're like going to his apartment to check if he's dead or something. I was like, where is this guy? I mean, things like that where it wasn't a good fit. We knew it wasn't a good fit, but I had to follow some processes. And now, I've been at Terracon long enough that that's not going to happen again.
So we'll wrap up with this one. Where do you think is the biggest opportunity for innovation in the design build process, and how do you best bring it in? I know that's broad.
Yeah, it's broad. So the problem we have with innovation is we can come up with some fantastic ideas, but then we have to get the DOT to accept it. Not to slam DOTs, but they have a spec that gives guidelines, and some DOTs are really great about being flexible and letting you try different things. Some are not so great. They want every letter that's in the contract. This is what you have to do. And they just don't allow any wiggle room. We had a client where if we were drilling for a bridge foundation, we had to drill like in the footprint of the foundation. It's like, well, we can't drill right there because it's the middle of something. Well, you better drill it before you build it. So we'd have to go back during construction and drill a hole exactly within the foundation. It was, it's like, is it really going to change over 10 feet? Probably not. But, some are very picky. Some are very picky, and there's nothing you can do about it. But innovation, yes, you can innovate, mostly with the contractors on the means and methods. I find that the contractors are most open to that kind of stuff if you have a really good contractor. Because ultimately, that's where you can innovate. You can't, the design stuff, it's really hard to innovate design things, and because they want to see where it's been done before, where's the precedent, that kind of thing. And they don't want you practicing on their project.
Well, I think that is going to wrap us up for today. Liz, thank you so much for this. I think this was a great presentation. Thanks to everybody who participated in the chat, asked questions, helped out when other people asked questions. We had some really great interaction today, and we really appreciate it. I hope everybody enjoyed this. We'll have 2 more of these scheduled with Liz, one in September, one in October. So you'll want to come back for those on the same GI YouTube channel that you've grown to know and love. You can find a ton of other stuff up here too, including things like the director's cut interview with Liz from earlier this year, where you can find out things like why she had to take chainsaws to drilling sites in Maine. I'm trying to think what else we talk. And she also sings the Virginia Tech fight song, which you'll want to stick around for too. So thanks again, everybody, for being here today. We really appreciate it. If you liked what you saw, always subscribe, get notifications from the YouTube channel, and we will let you know every time we post something new. So thanks. And thanks again, Liz, and everybody have a great day.
Thanks. Bye.